Good day everyone, I am Seifrit by Villavicencio together with my group mates John Kurt S. Angeles, Brgy T. Bolo, and this is the final progress report of our study entitled Seismic Performance Comparative Analysis and Concrete Design of Reinforced Concrete and Steel Frame Structure. A case study of three-story living quarters in Barangay Calanan, Tabuk City, Kalinga. So for the outline of the presentation, first is the midterm presentation revision or comments. Second is the action taken. Third is the steel connection design. Fourth is the reinforced concrete connection design. And lastly, the structural plans, which consist structural member sections, structural steel connections, and reinforced concrete RC connections. So for the midterm report comments, first is that we should omit the subtitles and the review of related literature. Second is we should transfer other figures to appendices. Third is we have to put figure caption below the pictures. And fourth, include the study aims and remove the first objective. As for the action that we have taken, we omitted the subtitles and the RRL part, as you can see in the picture. And for the next one is that we transferred other figures to appendices, particularly the architectural plan, concrete seismic drift values, and steel seismic drift values. And next, we put figure caption below the pictures, as you can see from this presentation. And lastly, we included these study aims and removed the first objective.
Good day everyone, I am T. Bolo, and I will be presenting you the general steps of the design of the steel connection design. We have here the classification of the steel connection family, the selection of the corresponding beams and columns. Sector is the determination of the governing structural member. For the presentation of the graphs and location of the representative member. E, the designing of the connection for the governing member. And F, is a presentation of the details and types of the connection. We have 17 connection family, and then the 3 is for the roof level, and since the third and the second floor is the same, that will be labeled as typical floor level, and the other for the stairs, the bracing, and for the footing. For the connection number 1, for the beam column web connection, the graph is presented in the location of the governing beam. We have here the design for the directly welded beam column web DWBCW with a utilization ratio of 0.31. For the connection family number 2, we have the beam column flange connection with the graph and the location of the governing beam. We have here the detailing for the beam column flange DWBCF with the utilization ratio of 0.31. We have here connection family number 3 for the roof level beam splice for the governing position. We have here the shear and moment diagram, and since the location of the higher moment is in the midspan, and for the theoretical idea of the placement of the splicing, we will place it for the L/3 of the beam length, so it will be 1.5 meters from the right side. So this is a design for the single plate beam splice SPBS with a utilization ratio of 0.29. We have here connection family number 4 for typical floor level beam column web connection. We have here the graph and the location of the governing beam. We have here the design for the directly welded beam column web DWBCW connection with utilization ratio of the 0.88. Next, we have here the connection family number 5 with the typical floor beam floating beam web connection with the graph and the location of the governing beam. And we have here the design for the flange plate beam to beam girder connection with its utilization ratio of 0.24. We have here the connection family number 6 for the typical floor beam girder web connection with a graph and the position of the governing beam. We have here the single plate beam girder SPBG connection with the utilization ratio of 0.62. And we have here the connection family number 7 for the typical floor floating beam girder connection with a graph and the location of the governing beam. And we have here the details with the single plate beam girder SPBG connection of 0.5 utilization ratio. We have here the connection family number 8 with the typical beam level beam column flange connection with a graph and the location of the representative beam. We have here the details of the directly welded beam column flange with a utilization ratio of 0.95. We have here the connection family number 9, which is the beam splice of the commonly used steel, which is W12 times 96. And since the higher moment is located in the midspan, so the splicing would be located in the midspan. We have here located a governing or representative beam with the single plate beam splice SPBS connection with the utilization ratio of 0.84. Connection family number 10 for the stair floor level beam girder with the location of the governing beam and the graph. We have here the single plate beam girder SPBG connection with a utilization ratio of 0.62. Connection family for 11 with the stair mid height beam column flange connection with the governing beam representative in the graph, and the design of the single plate beam column flange SPBCF connection with the utilization ratio of 0.48, and the connection family number 12, the stair internal column cap with the location of the representative column, and we have here the bolted column cap plate CC connection with the utilization ratio of 0.57. We have here the connection family number 13 for the column splice with the governing column in the graph, and we have here, since the moment is located in the midspan, so the splicing would be located in the midspan of the column. We have here the single plate column splice SPBS connection with a utilization ratio of 0.82. We have here the chevron bracing applied in the steel structure with the location of the chevron and the structure and the properties. For the connection number family 14, we have the chevron bracing top connection with the graph and the location of the governing beam. We have here the chevron connection top connection with a 0.87 utilization ratio. And for the connection family number 15, for the chevron bracing corner edge connection with the utilization ratio of 0.99 in the governing beam location. We have here the design of the pedestal and the putting of the steel frame connection created in the STAAD Pro Foundation Advanced software. We have here the isometric, the left side, the front side, the top view, and the connection family number 16 for the main column base plate connection with the graph and the location of the governing beam. And we have here the design of the fixed plate and biaxial axis with a 0.99 utilization ratio, and the last connection is the connection family number 17 for the stair column base plate with the graph and the governing column. We have here the design for the fixed plate and both axis connection with the utilization ratio of 0.99. That's all.
For the reinforced concrete design connection, there are three elements or members: beam, column, and footing. For the load cases and combination, we considered the series 1000. And for the process, these are the input of general and reinforcement settings, considering the cross-sectional area, ductile design, material properties, percentage steel, and stirrup spacing. For the column, we also considered the load cases and load combination. For the column is series 1000, and it is unfactored load. So for the process, we consider the design input, which are the steel properties and the covering. And for the design settings, this is the input and the process. The column percentage steel, longitudinal reverse spacing, and link spacing. And for the footing, since we cannot use the RCDC software, we use the STAAD Foundation Advanced. So since STAAD Foundation Advanced has combined footing, while RCDC has not don't have combined footing, so we use this. So the process is we model the footing depth and water table, soil property, and the properties of concrete and steel. For the load cases, for the size is the service loads, which is the series 2000, and the ultimate or the reinforcement is the series 4000. The serviceability is for sliding and overturning factor of safety is 1.5, and the increase of earthquake and wind is 33%.
And these are for the structural plan. First, we have the RC 3D model member section. These are the RC beam sections. These are the RC column section. And for the steel 3D model, we have also the steel beam section. And these are the steel column section. And the summary or the steel beam schedule.
Good day again. For the presentation of the structural plan, for the 17 steel connection presented a while ago, we have here the 8 pages of the plates of the steel connection. We have here for the page 1, we have the connection family here for the 1, 2, and 3 with the top view, lateral view, and the front view. And also, these pages will be presented in the appendices of the case study paper, presented in the last page of the paper. We have here for the second page, where the connection family number 4, 5, and 6. For the third page, we have the connection family 7, 8, and 9. And we have here for the connection family 10, 11. And here for the connection family 12 and 13. And here we're specified for the connection family 14 for the top bracing connection. And then for the connection family 15 for the chevron bracing for the corner edge connection. And we have here the connection family number 16 and 17, the last page of the steel connection structural plan. We have here for the base plate of the main column, and then the base plate for the stair column for the connection family number 17. That's all.
For the structural plans, since there are many sections for the beams, here is the example of the beam section. So for every location, there are respective section for the beam. So they have section and reinforcement. And here is the example for isolated footing, section and reinforcement. And this is the example of beam schedule. This is the example of column schedule. Thank you. Merry Christmas.